The next topic is the rocket propulsion. Okay, the rocket propulsion is also example of law of conservation of linear momentum. We will see how. Okay, so in a rocket, the gases are stored at high temperature and pressure. How? Because how are gases produced in a rocket? The gases are produced due to the burning of the fuel which the rocket contains. Okay, so when the fuel burns, the gases are produced at a very high temperature and pressure, which are ejected from the from the back of this rocket at a very high speed, and due to which there is a high change in momentum of the gases in the backward direction. So if the momentum is changing in the backward direction, so equal and opposite momentum is created in the forward direction. Okay, since there is a large change in momentum in the backward direction, so there will be a large change in momentum in the forward direction, and due to that large change of momentum in the forward direction, this rocket moves up or upwards in the space. Now what happens is, when since the gases or the fuel has a mass, and the gases which are produced or which are ejected from the back of the rocket are produced as a result of combustion or burning of the fuel. So if the fuel is burning constantly, what will happen? The mass of this rocket will keep on decreasing. Okay, so if the mass of this rocket is getting decreased, then the acceleration producing in this rocket will increase, and that's why that's why with the passage of the time and the rocket is moving in upward direction, its acceleration keeps on increasing due to the decrease in mass of the rocket. And why the mass of the rocket is decreased? Because the fuel is burning at a very high rate to eject the gases at a very high pace. So जितनी स्पीड से ये गैसेस क्या है बैकवर्ड डायरेक्शन में इजेक्ट होंगी, उतनी ही स्पीड क्या होगी रॉकेट को फॉरवर्ड डायरेक्शन में मिलेगी. ओके, सो नाउ वी विल लुक एट सम पैरामीटर्स ऑफ दिस रॉकेट प्रोपल्शन. तो यहाँ पे देखिए, द इनिशियल मास ऑफ द रॉकेट इज m naught. Okay, initial mass of the rocket means when the rocket is placed before the launch. Okay, so before the launch, the initial mass of the rocket is m naught. Now what happens when the rocket is about to launch? The fuel which is contained in the rocket is burned, and gases are produced at a very high pressure and temperature and ejected at a very high speed from the backward direction. So the rate of burning fuel or the rate of gas ejection is given by dm by dt, where m is the mass of that fuel. Okay, so dm by dt is the rate of burning of fuel. Okay, so now after the launch, since the gases are burning, so gases are burning means there will be some decrease in the mass of the rocket. So after the time t, when the rocket is launched, there will be some decrease in the mass. So mass of the rocket after time t from the launch will be capital M is equal to initial mass. Okay, initial mass and the rate of burning fuel multiplied by time. This will be the mass of the rocket at any instant after the launch, and it will be less than the initial mass because the gases or the fuel is burning continuously. Now if we say that delta V is the change in the speed of the rocket, in which direction? In the forward direction, and u is the velocity of gas ejection, means with u velocity the gases are ejecting in the backward direction. Okay, so as I have said that this is the example of law of conservation of linear momentum. So from the law of conservation of linear momentum, there will be the change in momentum of the rocket. This will be in which direction? In the forward direction, because the change in momentum of the gases is happening in the backward direction. तो जितनी तेजी से गैस क्या है नीचे की तरफ बर्न होगी in the backward direction, उतनी ही तेजी से क्या है रॉकेट ऊपर की तरफ जाएगा. And since the mass of the rocket is also decreasing, तो जो उसमें acceleration produce होगा that will be continuous. So इसके आगे अपन देख रहे हैं the change in momentum of rocket. The change in momentum of the rocket is the mass of the rocket at any instant, okay, multiplied by delta v, that is change in its speed or change in its velocity. This is equal to the change in momentum of gas. Momentum of gas means delta m. डेल्टा एम मैंने क्यों लिखा? बिकॉज वहां पे क्या है गैसेस का मास कंटिन्यूअसली चेंज हो रहा है या फ्यूल का मास क्या है कंटिन्यूअसली चेंज हो रहा है. ओके, तो इसलिए मैंने यहाँ पे लिखा डेल्टा एम बाय यू. यू इज व्हाट? द वेलोसिटी ऑफ इजेक्शन ऑफ गैस. अब इस पूरी इक्वेशन को मैं डिवाइड कर रहा हूं डेल्टा टी से, डिवाइडिंग इट बाय डेल्टा टी. तो यहां से मेरे को मिला m into delta v by delta t is equal to delta m by delta t into u. This delta m by delta t is what? This is the average rate of burning and this is the instantaneous rate of burning. तो both are same. Okay, so ये एक particular time interval के लिए होता है and ये एक particular instant के लिए होता है. तो delta m by delta t is what? The rate of burning of fuel. तो यहाँ से देखिए, now what you will do? यहाँ से put the value of this mass. तो यहाँ से आ जाएगा m naught minus dm by dt into t, and this dv by dt is what? Acceleration. This is delta v by delta t, means it is the value of average acceleration. Okay, so this is the acceleration a and this is equal to delta m upon delta t into u. यहाँ पे स्पेस कम है तो मैं इसको ऊपर लिख देता हूं. तो अब ये बन जाएगा, now this will become अब this whole term will go to the denominator part. तो यहां से acceleration acceleration produced in the rocket will be a is equal to ये पूरा टर्म कहाँ आ गया इसके डिनोमिनेटर में. तो ये हो जाएगा डेल्टा m बाय डेल्टा t into u upon m naught, that is the initial mass of the rocket, minus dm by dt, that is the rate of burning of fuel, into time t. So this is the formula for acceleration that is produced in the rocket. अब यहाँ पे net acceleration कितना होगा? Net acceleration कहाँ? जब gases are burning in the forward direction, so rocket is moving in the upward direction. तो net acceleration किधर होगा? Upward direction में. ठीक है? तो net acceleration will be a minus g, because ये जो a की value है that will be much more than g which is acting in the downward direction. इसीलिए तो जब a ज्यादा होगा g से तभी तो रॉकेट का ऊपर की तरफ मूव करेगा. इसलिए मैंने नेट एक्सेलरेशन क्या लिखा? a minus g. Now we will see first acting in the rocket. Thrust will act in the rocket. Thrust क्या है? It is the upward force acting on the rocket due to change in its momentum as a result of burning of fuel to produce ejection of gases at a fast pace. ठीक है, तो जितना ज्यादा क्या होगा बैकवर्ड मोमेंटम होगा उतना ही ऊपर क्या होगा, उतना ही ज्यादा क्या होगा फोर्स की वैल्यू होगी. ठीक है, अब यहाँ पे क्या था लॉ ऑफ कंजर्वेशन ऑफ लीनियर मोमेंटम में कि चेंज इन द मोमेंटम ऑफ रॉकेट, और वो चेंज इन द मोमेंटम ऑफ रॉकेट किसकी वजह से आया, ड्यू टू द चेंज इन द मोमेंटम ऑफ द gases which are ejecting in the backward direction. तो change in momentum of the rocket, सेकेंड लॉ में आपने पढ़ा है कि the change in momentum is called what, force, और वो change in momentum रॉकेट का किस डायरेक्शन में हो रहा है, in the upward direction, in the forward direction, ऊपर की तरफ. तो इसीलिए that change in momentum will exert a force on the rocket in which direction, in the upward direction. तो वही फोर्स जो रॉकेट पे exert हुआ है upward direction में, that force is known as what, this thrust acting in the rocket. और आपको पता है thrust की फोर्स की वैल्यू क्या होती है, फोर्स इज इक्वल टू मास इनटू एक्सेलरेशन. एक्सेलरेशन की वैल्यू आपको कहां, यहां से मिल जाएगी. एंड मास ऑफ द रॉकेट, मास ऑफ द रॉकेट ये वो वाला मास होगा, ठीक है, विच इज एट टाइम t आफ्टर द लॉन्च. और वो वाला मास कितना था, दैट वाज m0 माइनस dm by dt into t, and this will be multiplied by the acceleration which is produced, and this force is known as thrust, so I am writing it with capital T. Okay, this is clear. ठीक, अगर फर्दर आप इसको अगर सॉल्व करते हो तो यहाँ पे देखिए ये a की वैल्यू को यहाँ सब्स्टिट्यूट कर देंगे आप. तो a की वैल्यू अगर मैंने यहाँ सब्स्टिट्यूट कर दी तो ये हो जाएगा t इज इक्वल टू m नॉट माइनस बी एम बाई डी टी इंटू टी, और यहाँ a की वैल्यू आ गई मल्टीप्लाइड बाय डेल्टा m बाय डेल्टा t इंटू u अपॉन सेम m नॉट माइनस डी एम बाई डी टी इंटू टी. तो यहाँ से ये और ये कैंसिल हो जाएगा, तो थॉर्स की वैल्यू मुझे मिल गई रेट ऑफ बर्निंग ऑफ फ्यूल मल्टीप्लाइड बाय द velocity of ejection of gas. ठीक है, तो ये दूसरा फॉर्मूला है. If acceleration of the rocket is given, you can simply put the value of acceleration, rate of burning fuel, mass of the rocket, and you will get the value of thrust. Or if mass of the if rate of burning fuel is given and the velocity which the gas is ejecting is given, so you can find the value of thrust from that also. Okay, so now this brings to the end of this topic. So now I'm giving you some questions to solve. Now we will see some questions. One is based for finding acceleration and second is for finding the thrust. Sorry. Okay. So first question. This is the question from your NCERT. What does the question say? We will look at it. A rocket of initial mass 6000 kg ejects mass at a constant rate of 16 kg per second. Ejects mass at the constant speed. This is the value of rate of burning of fuel, which is dm by dt. Dm means mass is in kg and dt is speed, so kg upon second, kg per second. This is ejects mass at a constant rate, means this is the rate of burning of fuel with constant relative speed of 11 km per second. 11 km per second. This is the velocity with which the gas is ejecting in the backward direction. What is the acceleration of the rocket a minute after the blast or a minute after the launch? So first we will write the parameters which are given in the question. तो पहले क्या दिया है, initial mass. Initial mass was what, m naught. M naught is given 6000 kgs. Okay. Ejects mass at a constant rate of 16 kg per second. This 16 kg per second is what, rate of burning of fuel. Rate of burning of fuel was dm by dt. Okay, so this is dm by dt, which is equal to 16 kg per second. Okay, and constant relative speed of 11 km per second. This 11 km per second was the velocity with which the gas is ejecting. So this is 11 km per second. So this you will convert it into meter per second. So this will become 11,000 मीटर पर सेकेंड। कैसे आया? सी, दिस इज 11 किलोमीटर per second. So 11 kilometer will be converted into meters. So 1 kilometer is equal to how many meters? 1000 meters. So we will multiply this whole equation by 1000. So इसलिए ये आ गया, kilometer will be converted into meter. Okay. So this will become 11,000 meter per second. And next value is time, that is 1 minute, and 1 minute is equal to how many seconds? 60 seconds. Now we will apply the formula for acceleration. क्या acceleration का formula था? A was dm by dt multiplied by u upon m naught minus dm by dt into u, sorry, into t. ओके, तो यहाँ से वैल्यूज पुट कर दीजिए सारी। आप वैल्यूज आपने पुट करी तो ये हो गया dm by dt कितना है? That is 16 into u is how much? 11,000. This is multiplication, okay, and upon is m naught. M naught is how much? 6,000 minus 11,000. dm by dt is how much? dm by dt is 16. dm by dt is 16 into time. Time is what? 60. Okay, so if we calculate this, it will become 16 into 11,000 upon 6,000, and 16 6 is 96, means it will become 960. So if you subtract 960 from 6,000, it will become 5,040. So this value will become 5,040. Please check it if I am not wrong. 16 6 is 96. 96 into 10, 960. 960 minus 6,000 minus 960 will become 5,040. Okay, so this is correct. So after cutting this, this will be by 16 3s are 48 and 42 is 24. Okay, so this will be cut by 4. So this will become 4 1s are 4 and it will become 2 and 126 and 4 4s are 16. Again this will not cut by 5, this will cut by 2. So from here it will come 2 2s are 4, this is 6 and this is 3, and now it will not cut. Okay, so if you will calculate this, you will get the value. How much you will get? 34.92. 34.92. This will be meter per second square. Okay, so you will get approximately 34.92. The next question. The next question says that the fuel is consumed at a rate of 100 kg per second. 100 kg per second is what? Rate of burning of fuel in a rocket. The exhaust gases are ejected at a speed of 4.5 into 10 to the power 4 meter. This is the velocity with which the gas is ejecting. So we will write the parameters which are given in the question. This is dm by dt, which is also equal to delta m by delta t, and this is given 100 kg per second, and u is given what? U is given 4.5 into 10 to the power 4 meter per second. So I have derived the one single formula for the thrust, which was, it was dm by dt into u. Okay, so from here you will get the value of thrust as dm by dt is 100 into u is what? 4.5 into 10 to the power 4. So you will get thrust is equal to 4.5 into 10 to the power 6 Newton, because thrust is a kind of force which acts on a rocket in a forward or upward direction. So you will get the value of thrust as 4.5 into 10 to the power 6 Newton, and you will get the value of acceleration as 34.92 meter per second square. So this was the end of the topic.